Hi, this is GK Trick India and I am Saghnik. So today we are going to talk about the chemistry of alkenes and we are going to discuss few important reactions of alkenes. Generally, we are going to discuss some of the very important substitution chemical reactions of alkene. The substitution chemical reactions are those in which one atom or group of atoms in a molecule is replaced by some other atom or group. Alkenes undergo substitution reaction in which one or more hydrogen atoms are often replaced or substituted with the help of various reagents by different atoms or groups such as halogen atom like chlorine, bromine or iodine, nitro group like NO2 group, or sulfonic acid like SO3H group. So let us discuss some of the very important reactions. So the first, we have chlorination reaction. Here, this involves replacement of one or more atoms of alkenes by corresponding number of chlorine atoms. For example, here you can see the alkene is treated with chlorine in presence of diffuse sunlight or ultraviolet light or heating it at a temperature of 523 to 773 Kelvin. Note that this is a very high temperature. So during this reaction, we get, as you can see, we get a mixture of products like chloromethane, that is methyl chloride, dichloromethane, where 2 hydrogen atoms are replaced, trichloroethane, where 3 hydrogen atoms are replaced, or very popular carbon tetrachloride, which is used as a solvent in many reactions, where 4 hydrogen atoms are replaced. Generally, it takes place in steps following a free radical mechanism, which involves a chain initiation step, a chain propagation step, and a chain termination step. Talking about the reactivity of this, generally the replacement of hydrogens of the alkenes occur in this order: 3 degree greater than 2 degree greater than 1 degree, which means tertiary hydrogen atoms are replaced at a faster rate than secondary, which is even replaced at a faster rate by primary hydrogen atom. Next, coming up next, we have another halogenation reaction where we produce fluoroalkene. This is popularly known as Swarts reaction, where the CF bond is prepared using mercurous fluoride. Note that here one haloalkene has been replaced to form another haloalkene. Chlorine is replaced by fluorine. Also, another reagents that are popular for this kind of reaction is ASF3, arsenic trifluoride, SbF3, or Hg2F2. Generally, preparation of fluoroalkenes are difficult as they are very reactive, but these kind of techniques helps them produce at an even rate. Going on next, we have very popular sulphonation reaction. In sulphonation reaction, one hydrogen atom is replaced by SO3H group. As you can see, SO3H group has come out in place of one hydrogen atom. The alkenes undergo sulphonation with fuming sulfuric acid at high temperatures like 675 Kelvin. The higher alkenes undergo sulphonation to give alkane sulfonic acids. The ease of the substitution reaction is again tertiary greater than secondary greater than 1 degree. So as I can tell you, this is a primary alkene, this is a primary one. Primary hydrogen is replaced, and out here tertiary hydrogen is replaced. So this one occurs at a faster rate because tertiary hydrogen atom has been replaced by H2SO4 and SO3, that is fuming sulfuric acid. Going on next, we have a complete oxidation or combustion reaction. You must be knowing that alkenes are generally represented by the formula CnH2n plus 2. Alright? So these react with 3n plus 2 by 2 molecules of O2 to produce n molecules of CO2 and n plus 1 molecules of H2O. Okay? So the coefficients that come here come due to the balancing of the reaction. And these are, you must be knowing that alkenes are very highly combustible in nature. They burn in air or oxygen, giving carbon dioxide, water, and liberate large quantities of heat. During the combustion, the large amount of heat is evolved, and therefore hydrocarbons are also used as fuels, like cooking gas. Often uses LPG, that is liquid petroleum gas, and is a mixture of propane and butane. So you must be realizing by now the importance of alkenes in our daily lives. Going on next, we have a reaction of controlled oxidation. When the combustion is carried out, insufficient supply of oxygen or other interesting reagents are used, like out here MO2O3. We get that MO2O3, that is molybdenum oxide, under pressure and heat we get methanol or formaldehyde. This is a case of controlled oxidation. Going on next, we have another example of controlled oxidation reaction, where the alkane is oxidized in presence of copper tube. In presence of copper tube in 523 Kelvin and 100 atmosphere to give methanol. The methane and oxygen are in the molar ratio 9:1. 9:1 ratio. So you must be realizing that methane has excess and hydrogen and oxygen gas is in less amount. So obviously the complete oxidation cannot take place to produce carbon dioxide and water. So before proceeding, please like, share and subscribe to GK Trick India for more such educational videos by some genius educators. Going on next, we have oxidation of tertiary alkene. Here the tertiary hydrogen atom is replaced by OH by the process of oxidation using alkaline KMnO4. You must be knowing that alkaline KMnO4 is a very strong oxidizing agent, and thus it has even the ability to oxidize the alkenes having tertiary hydrogen to alcohols in the presence of potassium permanganate KMnO4. Here 2-methylpropane has been converted to 2-methylpropan-2-ol. Thus you can even think of it as another method of preparation of alcohol. For the next reaction, a very important reaction which has a large scale industrial application, is the reaction of isomerization reaction. Now what are isomers? Isomers are generally compound having the same molecular formula but different structure. Here you can say that N-butane and isobutane are basically structural isomers. So basically the CH3 group has been come up here to give isobutane. Here in this reaction, alkene isomerized to branch chain alkenes when heated with anhydrous aluminum chloride. Note that it is anhydrous and water is not used in this reaction. Anhydrous aluminum chloride and hydrogen chloride gas at 573 Kelvin under pressure for about 30 to 35 atmosphere. Note the reaction conditions. 573 Kelvin with 30 to 35 atmosphere of pressure. The process of isomerization has been of immense use in the petroleum industry for raising the octane number of petroleum fraction. Proceeding next is another important reaction. The alkenes containing 6 or more carbon atoms, when heated at about 773 Kelvin under high pressures of 10 to 20 atmosphere in the presence of catalysts like oxides of chromium, molybdenum or vanadium, and supported alumina gel gets converted to aromatic compounds. Out here, benzene. That is, a compound containing 6 carbon atoms, that is hexane, N-hexane, is converted to benzene. This process is called aromatization, so it can be reused as another method of preparing aromatic compounds. Next comes a similar example out here is the preparation of toluene, that is methylbenzene, from heptane. Heptane contains 7 carbon atoms, and the same reaction conditions it gives an aromatic compound with 7 carbon atoms, that is toluene. So let me summarize it. So we have learned today about the aromatization reactions from N-hexane to aromatic compounds, isomerization reaction where branch chain alkenes are formed with anhydrous aluminum chloride, oxidation of tertiary alkenes where one tertiary hydrogen atom gets replaced by alcohol using strong oxidizing agent, control oxidation using copper tube at elevated temperature to give methanol, with molybdenum oxide to get methanol, that is formaldehyde, complete oxidation or combustion reaction, which has a huge application in our daily lives. Next comes, also we have talked about sulphonation reaction, where one hydrogen gets replaced by the SO3H group under fuming sulfuric acid condition. One chlorine gets replaced by fluorine in the very popular Swarts reaction, and the most introductory one, the chlorination reaction or the halogenation reaction, where chlorine atom gets into the alkene to give methyl chloride, methylene dichloride, chloroform or carbon tetrachloride in presence of heat or light. So that's it for today. Thank you.